name is Gerard. I will be handling today's session for you. So, the basic thing for any circuit is the power supply to the circuit. Okay. If it's in large scale, like it's for a house, we call it as electricity, and for small circuits, we call it as power. And in our house, you can something like this is available for you to plug in your mobile or laptop, right? Okay. So this is what you find in houses, right? So what comes out this is called as the AC supply. AC stands for alternating current. Okay. And this is around 220 volts. So AC stands for AC current. So this is what our household we use for your tube lights, fans, TVs and all. We use AC current, AC or AC supply in short we say. For circuits that we'll be doing will be DC supply. Okay. DC stands for direct current. So this is what is available in your cars, your mobile phones. Your mobile phone is working with some power supply, right? So that power supply is basically your power supply. So you should have seen this battery in your so this is so we are going to use only this power supply for our circuits. So now look into the basic components that is there for doing simple electronic circuits. So we'll be covering all these topics. So the first component that you're going to see is resistor. The resistor basically is something that blocks the flow of current, okay, by which we can reduce the voltage that goes into the output device. Like suppose I have a small LED. My image is visible. Okay, can you see LED on?
Yes, sir.
Yes. Okay. So if I connect this LED straight away to a battery, my power supply, this LED will burn out. In the sense it gets spoiled. So to limit the supply current that goes to this, we'll be using this resistor along with this. So this resistor basically is a component of an electronic or electrical term called resistance. We have a term resistance meaning blocking something. So when you're riding a bicycle, okay, we are going at a good speed. What makes you slow down? Riding a bicycle. Yes, so this resistance is like something like a speed breaker which slows down or brings down the voltage so that it is sufficient for this LED to glow. Okay. So this resistance is measured in terms of ohms, OHM. Can you write the term? OHM. Resistance is measured or is referred by the unit ohm. Resistance is referred by the unit OHM, and the symbol is something like this. OHM or ohm, you can see Ohm's law. So resistance is the unit for resistance is ohms, and the symbol for that is the omega symbol of the Greek letters. Okay. So each resistance, you can see how many you have different colors, right? Can you see those boxes? Can you see different colors in resistance? In my hand I have 2 different colors, and in each of them they have lines. Can you see those lines? Yes, graphical resistor calculator. Now I'm giving you an exercise. So all of you have some resistors in your with you. You have to hold the resistor, the gold color on your right side. Your right hand should be holding the gold color. Okay, your right hand, like I'm holding. If I'm not sure if you are able to see, this gold color should be on my right hand, in your right hand. So holding in such fashion, you can select the. Now I'll share the screen. I'll share another screen for you. 1 second. Okay, so this is what you see, right? This is what you're seeing. Snow, fall. Okay. So make sure you're holding this gold color on your right side and select the colors that you find in the resistor. So I'm finding yellow colored, and then a purple color, sorry, it's violet actually. It's violet and then a red. So it gives me the value for the resistance. Can you see? It gives me the value for the resistance, 4.7 kilo ohms. So the resistance that I'm holding is 4.7 kilo ohms. This exercise you have to do for at least 2 or 3, at least for 2 resistors, and all of you, I want you to do this exercise and put the value. Ohm's law formula. Okay, I'm not going to explain you that, because basically it is the ratio between the voltage and current. The current that flows through a circuit is the ratio between the voltage and resistance that is there in the circuit. You can note down this particular formula. As of now. Ohm's law is equal to I is equal to V by the current that is there in the circuit is the ratio between voltage and resistance in that circuit. So the next component is capacitor. Can you see this capacitor in the components? So capacitor is used to store charges in the circuit. Whenever the circuit is when the flow of current through the circuit is missed out, this capacitor will save a small amount of charge that is stored into the circuit. So this will keep the circuit alive for some small duration. Even if there is no input in the circuit, this capacitor will keep the circuit alive for a small duration of time. The capacitor is measured in terms of farad, and these are the 2 types of capacitance that you see. One is ceramic disc capacitor, that is this one. The other one is ceramic disc capacitor, and the other one is electrolytic capacitor. So whereas you can see this fellow, it's not having no polarity, whereas this has a polarity. Polarity means it will have a minus symbol. You can see on the cover, this minus symbol. Can you see that? If you take that cylindrical capacitor, if you take the cylindrical capacitor, this capacitor, okay, there is a minus symbol. So this one has polarity. This electrolytic capacitor has polarity, whereas your this capacitor does not have any polarity. Electrolytic capacitor, it's a thin small one is a disc capacitor, ceramic disc capacitor. The other one is electrolytic capacitor. It can be used for both AC and DC. Okay, next is diode. So diode actually will allow current to pass through one direction. So it will allow current to pass through only this direction. It will not allow this way. Okay, this is not allowed. So diode is a component that allows current only to pass in one direction. Okay, so that's about diode. We will not be using much about the diode in our circuit. So this is used exclusively when you are converting AC to DC voltage. Next is your transistors. So this component is used to increase the voltage, increase the current to required level for our circuit, in our circuits. Okay, so say suppose I get some small some 10 milliamps current, I can increase it to 15 S that is the one. I can increase this to 15 amps or 20 amps based on my circuit. Okay, so this transistor has 3 pins. Okay, so how to identify, and each of them has a name called collector, base, emitter. So pin number 1 is collector, 2 is base, 3 is emitter. And in the symbol also you can see emitter holds a small arrow. So whenever you see this arrow, we should understand that is the emitter pin. Okay, so here this is the emitter. Okay, this is the emitter for this PNP transistor. What you are having is a NPN transistor. So now another exercise. I want you to put this transistor on a white paper, okay, on a white paper like this, and write the name. So you have to hold the flat side facing you. Okay, the left one is pin number 1, middle one is 2, and the right one is 3. Make sure you're holding the flat surface towards you, and left one is pin number 1, middle one is 2, right one is 3. So I just want you to do.
Yeah, sir.
Can you see that now? Like this, I want you to draw in your keeping this. So the flat surface, put it on the book, write collector, base, emitter. Put that transistor on your notebook, the flat surface facing you, and write collector, base, emitter. You can write the pin numbers also if you want. You can write the pin number. So pin 1, 2, 3, you can write that. So next is, this is called an IC. IC stands for integrated circuits. Okay. So this IC will have a lot of components into it. Okay. Make into one small chip. Whatever IC you are having, if you see the number at the bottom, you can see the number. It will be 555. We are having an IC called 555 IC. It is almost having 40 components inside it. We are seeing components like these, right? So like this, there are 40 components inside this one IC. So whatever IC you are having is a 8-pin IC. 1, 2. You can, if you count the number of legs, you can find it will have 8 pins. So this is a 555 IC that I'm having. Quite small. Okay. So if you flip it, you can see some small legs, right? So those are the pins. It is having 8 pins. Okay. So how will I find which one is the first pin? You can see there's a small notch over here. Can you see that small notch over here? I want all of you to find out that notch in your IC. Take the IC, find that notch. Up straight, holding the notch on top side. The left pin is the pin number 1. This is the pin number 1. Okay, this is the, so you can see the notch on the left side. This is pin number, okay, and this is pin number 8. So you can count 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8. So like that we can count and we can identify the pin numbers. So each pin has its own functions. So as we go into the experiments, that time we'll see what is the function of each. Okay, so this is potentiometer. What does this do? Basically, it is a resistance only. Okay, it is a resistance only, but you can change the value. You can change this resistance value. So like the resistor that we saw in the first slide that we saw over here, yes, thing is a resistor which is constant and you cannot change the values. Whatever value we saw 4.7k, we saw 330 ohms, 470 ohms, etc. All those are constant ones. We cannot change. But here we can change the resistance value. So if you can see on top, you will find what is the value of the potentiometer. So you can, this potentiometer, you can vary the resistance. So you can get some, instead of 330 we can get 300 also, instead of 500 we can get 550 also, like that. Okay, so again I want you to identify the pin terminals, like pin number 1, 2 and 3. So you put your potentiometer on the paper as shown in the previous exercise. Do for potentiometer also. I want to do for potentiometer also. Can you do that? Good. I see people drawing. VCC is your VCC, and by the side of the VCC you can write it as plus also. So we can do it like this also. Plus, minus. This also is correct only. Minus, plus. Because we are operating these battery source, I'm keeping like this. So you've seen LED. Okay. So this LED, basically LED stands for light emitting diode. So this light emitting diode also has 2 pins. The longer one is called anode, which is positive. The shorter one is called cathode, which is negative. Okay, you can see the legs over here. The longer one is called anode and the shorter one is called cathode. So this fellow will, if you the battery that you're having, if you connect the battery straight away to this fellow will go wrong or go bad. It will fuse off. So this fellow will require very low current to glow. So whenever we are using this LED, we'll use it along with the resistor, a small value of resistor, something like this. Okay, we'll be using a small value of resistor along with the LED. We'll be making this circuit. The next is switches. Basically it will establish a connection between the fan and the power source. So all of you have a battery. Battery is something, a chemical that is there inside a metal sheet. which is able to store charges. Okay. This can store for a longer duration. Batteries can store for a longer duration and can discharge slowly. And batteries are represented like this in the circuit. Batteries are represented like this in a circuit. This is called bread. Does it look like a bread? Why is one fellow who wanted to make a circuit, he was searching for something to place. At that time in his house, he found a board which was used to cut the breads. Okay, it was used to cut this breads in his home. He used that board to make this circuit. So from then on, whatever prototyping boards people are using, it is called as breadboard. But there's no relevance for bread over here. Okay, so here in this, you can see vertical, you can see lines like this. Are you able to see this thing on top of the breadboard? This one and this one. Okay, internally it is like this. There's a small metal, the base. One is vertical, the edges are vertical, the center ones are horizontal. So that is what you are seeing in the diagram. So it is connected like as you see the connections over here. So this breadboard is used to provide connectivity internally, but we just plug it on top. Internally at the bottom, what I showed is the metal that is there to provide you connectivity. Okay, so whatever circuits we'll be doing this on this particular breadboard. What is this? Why we use wires? Yes, to supply electricity or to provide some connection between. Don't open, or to provide a supply from to provide continuity between components also. Okay, this is why we provide wires are used in the circuit, and we will start doing this particular circuit. So connect the battery. Now I want you to identify a 330 ohm resistor that is there in your components. So the 330 ohm resistor, what is the color? If people are having this color combination, orange, brown, he'll be showing the demo. Take one color LED and the battery and the battery connector. Take the battery and the battery connector. So these are the components required for this particular first exercise. The LED and the resistor. See which one is connecting first. So he's taking the cathode. Okay, he's taking the cathode. Yeah. Connect the anode and the resistor. Connect the anode and the resistor. So he's placed the LED, and now he's connecting the resistor at the anode. Same line. Can you show it closer? The same line. See the one pin of the. If you can see it, you can see this. You can see the pin of the anode pin of the LED, and one leg of resistor is connected. I just hold it still. You can see this. So anode and the resistor. Just you can do 2x. Need not move like that. Just do 2x. That's enough. Just hold it straight and do the 2x video. Hope you are able to see that connection. Yes. The wire from the so other leg of the LED is black wire, and the red wire to the. Can you see that? So one question here. Why did we use this resistor here? It's to resist the current that goes to the LED. Okay, so to bring down the current that goes to the LED so that it glows to a certain extent. So next is I want you to introduce a switch. Okay, next is now let us control when to turn on this LED and when to turn off this LED. So we'll introduce a switch in between the circuit. So now we need to introduce the switch in between the battery and the resistor. So we'll introduce the switch in between the battery and the resistor. So you have a switch, right? See, that's a switch. See what he is doing is he is taking two wires and connecting it to that switch that you're having. See that? Like that you have to connect two wires. To the switch you have to connect two wires. So like this you connect two wires to a switch. You're having wires right with you? Yes or no?
No, sir.
Okay, now you use this. See, now sir is connecting that between the resistor and the battery. Switch is connected between the resistor and the battery. You can see that. See there. So between the resistor and the battery, you can see between the resistor and the battery, the switch is connected. And have it with you, and you can keep adding as many as LEDs possible. See, now with the same battery we are connecting more than one LED. Okay, you can draw the circuit with the same battery. We are connecting more than one LED. Ranjit, can you show a demo for this? See, Ranjit sir is showing demo for more than one LED.
It's working.
Arjun, good.
Thank you, sir.
Water light is the other one is not glowing. Why? Connections you have to do it properly, otherwise it won't glow. It might have been fused also if you're not doing it properly. The long leg is plus, the short leg is minus. Okay, sure.
Okay, sir. Thank you, sir. Shall I leave?
Yeah, you can leave. Those are completed, may leave. Jovan, completed? Okay, Jovan, you can leave. Good man, good. Okay, so you can leave.
Thank you, sir.
Nakshatra, good. You may leave.